Hello YouTube and greater internet out there. It's been a minute since I've done a video, and I thought I'd get back into the swing of it by updating an old video that I did on IP tables. I was looking at the comments and somebody said it was a great video and tutorial or whatever, and I really appreciate that comment. That's awesome that you guys like it. However, I noticed one glaring thing about it, and that is it has aged considerably. And there are newer technologies out there that we can take advantage of. And so today I'm going to try to show you how to do that. So as you can see on my screen here, I've got two virtual machines running, one on the right, which is a client virtual machine over here, and one on the left, which is a router virtual machine on over here. So that's what it's going to be when we get done with this, and I hope that's exciting for some of you because this is going to be considerably more advanced, although rather simplistic when it all boils down, than the original tutorial, which just showed you how to filter packets. This one's actually going to get into natting, which is kind of awesome. So I wanted to show you some more advanced concepts in this one. And so basically the goal here is going to be to get this right machine to be able to ping out of the network, maybe like google.com or something, through this left machine here. So right now, if you notice, I can't ping google.com. You can see that it's not doing anything. It's going to time out and just be kind of blah. It's not going to do a thing. So I can, however, ping the IP address on this machine. Now, hopefully you can see this, but it's kind of small. So if you have a low resolution screen and can't see it, it's not that big of a deal. I'm not going to be doing a lot of work in these two terminals down here. These are SSH sessions to these various machines. So this one is an SSH session to this one on the right, and this is an SSH session to this one on the left. Hopefully you guys can follow that okay. So I'm going to ping this router and just make sure we can talk to it. And I say router with air quotes right now, because right now it's just a Debian machine. And I do want to specify specifically that these are the same computer, right? I literally just built one and then cloned it. So it's using the exact same operating system. The only difference between the router and the actual client is I've made some changes to some files already to test that everything I'm going to show you works. I've done kind of a dry run on this, so I've put some config files in place as placeholders that I can kind of read to make sure I've got myself on track and I'm not showing you something incorrect, and I keep things in the correct order so that you guys can kind of understand it. You know, a tutorial is only good if it's all in the right order and it actually conveys the message that I want it to convey. So that's why I did that. So anyway, let's go ahead and get back to pinging this guy. So we want 192.168.100.133. Too many threes. Okay. So you can see here that it will in fact ping the other computer, and vice versa too. So if I do ping here, right, 192.168.100.190, you can see that they talk backwards and forwards, right? And that is with no network filter rules of any kind. We're completely fresh out of net filter rules right now. So that's a thing. All right, so I'll go ahead and Control C to end those pings there and clear these terminals to make this easier for you to see. Okay, so the next thing I want to do is start working on the prep work to make this thing a router. So there's a couple of things you need to do to make it a router. The first thing you're probably going to need to do is if it does not exist and is not installed, you need to install Nftables. So that's going to be sudo or just su to root if you've not configured sudo. Sudo apt install Nftables. And you'll notice that mine is already in the newest version because, like I said, I did a dry run on this video. You know, there's going to be some extra stuff that I don't necessarily need to do that you might. So that saves you the pain of watching me install Nftables, I guess. It's really quick. Let's just take you like a second. Anyway, so now that we have Nftables installed, hopefully that went smoothly for you, we can go into the sysctl.conf file, which is located in Etsy. And as you know, as you can see, most of the work here is going to be done in Etsy because I'm in the Etsy directory. So if you're not in the Etsy directory, cd to Etsy and go ahead and be there. So we're just going to take a look at the sysctl.conf file. So if we do that, sysctl.conf, this is what this file will look like by default. I recommend you make a backup of this. I've made several. I made one that's actually pre-configured so that it is the way that it's going to be at the end of this video, and I have one that is in the original configuration. I recommend you make one that's at least in the original configuration. So there are two things we need to do here in order to make this a router. Now, before we do this, I want to prefix this with, I'm not going to show you IPv6. This is going to be IPv4. To do IPv6, you'll do the exact same things I'm doing with IPv4, except you'll use the IPv6 side instead or in addition to. So the first one we're interested in here, if you notice, there is an IPv4 forward here. We're just going to uncomment that. And you can see below there's an IPv6. So if you want to use IPv6, you'll uncomment that as well. Why am I not using IPv6? Because I live in America and my ISP is lame and we don't use IPv6 over here yet. So that would be why I'm sticking to IPv4 in my case. We can look at this guy. So it says here, do not accept IP source route packets. We are not a router. Well, as you saw by this video, we are a router, so we're going to go ahead and change this, and we're going to use the value of 1 there. And by the way, I'm using the Vim text editor here. If Vim is complicated for you guys, or you can't figure it out, or you're new or whatever, you can switch to a product called Nano. That's N-A-N-O, Nano. It's another text editor that might be a little bit easier for new people. I personally can't stand it, not because it's a bad text editor, but because it's limited on features and I like having Vim. So I will use Vim. But you guys can use whatever you like to edit these files, whatever you're comfortable with. So once you've got these files edited in that fashion, or IPv6 enabled as well if you want, you're good. You may also notice this other do not send ICMP requests. We are not a router. You can optionally enable that if you want ICMP to be routed. I personally prefer ICMP to not be routed from the router. You can still use that internally between your computers, just it won't go between your two ports and such. So so you can leave that optionally disabled. If you decide you want it, you can always turn it on. And so that's that. Okay, so that's all you really need to do with the sysctlconf. Now, what you can do is you can either reboot now that you've changed that file. Sysctlconf is the default file that it will read, or you can type the command sysctl, I need to sudo this, but sysctl, and then tac lowercase p. Right. So if you add a file here, so if I did like sysctl conf, and then something else or whatever, if I had another configuration file I wanted to use in a different directory that I've backed up somewhere, I could totally specify that there. I could even give it path to whatever path to conf.conf, whatever whatever file I wanted. But if you just leave it blank like that, you will load the default configuration file. If all has gone well, you'll see the two values you've changed as output, and you're good. That's it. At this point, your router should theoretically start working. However, if we come back over to our client, you'll notice that if we ping google.com, what we have done is not enough. This will not route packets. So we need to set up routing. So how do we actually do that? Well, let's take a look at our Nftables, net filter tables configuration file, which is in Etsy as well. So sudo by, or nano in your case, if you're using nano. And then you want to use nftables.conf. So in here, you'll notice a very simplistic looking deal, and this is where you're going to put your rules. Okay, so IP tables generally gives you the 3 different tables. You have your filter table, your nat table, and your mangle table. Those 3 tables tend to exist in Nftables as well, but the only one that is defined by default is your inet filter, and this is your definition for that. And this is a definition where it has a blank rule set. So essentially all 3 chains are blank. So the terminology here is you have your table, which is sort of like the overarching collection of rules for the entire table, right? And you have 3 of those, and they do different things. So your filter table is more like your firewall. Your nat table is where you're going to do most of your routing work, and then your mangle table tends to be for modifying packets, and you're not really going to use that. It's rarely ever used. However, you can use it if you want to do things like QoS or quality of service, but that's a little bit outside of the scope of this. as far as I know anyway, as far as I've researched. But again, it's rarely used. So your inet filter is there by default because that is like the bread and butter table that you want to use for different things. And so the first thing we're going to do with our inet table, this was actually pointed out by a commenter in my prior video, is we're going to make sure that we allow SSH, because without that, if we're on a remote system and we're SSH'd in and we enable rules and we don't have one for SSH, we're going to lose our connection and our ability to reconnect as well, and we may be stuck without a server depending on if this system is in a different state or in an AWS cloud or something. It may be you're going to lose connectivity to that system, and you might not want that. Granted, if you're using this and you're in AWS, you're kind of doing it wrong, because AWS has its own security groups and its own sort of mechanisms for doing this, and it's kind of silly to mix the two in my opinion. But anyway, so at this point what you can do is you can start on making your rules, and your rules look like this. You have IIF, which stands for input interface, okay, and then you want to do ENP1S0 in my case. Now that is because, I'll put these up here for you. Now this is just a comment, so it's not actually going to do anything, but just so that you kind of can remember which is which, and maybe for my own benefit as well. ENP2S0 will be the local or the LAN, and the WAN is going to be ENP1S0. So anytime we're talking about our WAN card, it's ENP1S0. Anytime we're talking about a local card, it's ENP2S0. So just look up there if you can't remember or get confused. Okay. Again, anything preceded with a hash like that is a comment and will not be interpreted. Okay, so next thing we're going to do is we're going to go ahead and do TCP, because it's a TCP port we're going to unblock. We're going to do D port. And then here, this is a stylistic choice that I like to make. So the explanation here is that the SSH, you could also use 443 if you like there. It'll take the number or the known port name. But if you have a known port like HTTPS or SMTP or SSH, it will understand that and interpret that if you want. So yeah, you can do that. The other stylistic choice here is the curly braces. So the curly braces are only actually necessary in the case that you have a list of different ports that you want to actually utilize, or a list of objects that you want to manipulate. And in this case, we're only going to have one. So you don't necessarily require the curly braces here. But I like to put them anyway because I think it makes it stand out a little bit better. It makes it a little bit more readable in my opinion. And if I decide I want to go in and update things later or add something to it, then the curly braces are already there for my convenience, and I don't have to worry about it adding them later or forgetting to add them and then coming up with errors. It will not error out or have any kind of issue with you putting them in there when they're not necessary. But if you mess up and you leave them out when they are necessary, it will error. So that's something to understand. Now the other interesting thing about Nftables, and this is something that really kind of threw me for a loop, which by the way is what I'm attempting to cover here, are all the things that I found really, really difficult to sort of figure out, and all the things that had me Googling like crazy, and I seemed to have a really hard time grasping or had a hard time getting a straight answer via Google. So one of the more irritating things about this was replicating a feature in Iptables where you have the command Iptables tac capital L, tac N, and tac V. And what that did was it showed you a breakdown of your particular table, and it gave you a packet output so that you could see what packets are flowing through which rules, and it was easy to determine if your rule was actually working the way you think it was working, or if your rule wasn't working, or if your rule was being ignored, etc. and so forth. So it's a good way to tell what your rules were actually doing. And figuring out how to do that in Nftables was actually rather difficult. But the good news is I did actually figure out how to do it. And so the easiest thing to do is to add the word counter to the end of your rule, just before you do your action, which in this case is going to be accept, ACCT. And then you can add a comment as well if you like. And you can quote the comment, and we'll just put allow SSH, okay? So that's the whole rule in and of itself. Again, counter is optional, but it will give you the output of if packets are actually flowing on that particular rule or not. And I'll show you that a little bit later. Okay, so the next rule we're going to add is going to allow local packets in. So IIF ENP2S0. We're going to trust everything on our LAN and assume everything on our LAN is good. You don't necessarily have to do that Like for instance, if you had an open LAN or something, or you had LANs that you know other people are going to connect to, or maybe you're just paranoid and you want to make sure that you're protecting yourself from insider threats, you can be more stringent on this if you like, but I'm going to go ahead and assume that every system on my LAN is a good system or is not trying to kill me or something. So we're just going to do this, and we're going to do allow local packets. Okay, now again, you can make that more stringent if you like, for whatever reason, but you're probably going to want to do something similar to that so that packets coming into your LAN system are going to be allowed. And then from that point, you can do IF EMP1S0 CT state. Now, so what I'm doing here is I'm going to make sure that packets on our WAN port can come back in if we requested them. And this is, we're looking for the state on these packets to be established and then related. Okay, so this is actually going to make sure that if I say I'm browsing a website, right, and I ask for a website, say google.com, if I don't have this rule, then what will happen is I will not be able to get the response back from google.com. But what that rule does do is if a packet is coming from a system that did not result or was not in a result as a result of my request, it will deny that packet. It will not match this rule, right? And so what's important there is basically only packets that are related to an established connection like a web browser will be accepted, and that's the important thing. You don't want to accept packets from some random person who's just trying to connect to your systems. What you do want to do is you want to accept packets from some random server that you're requesting packets from. So that's what the established related thing does. And for this we can also add a counter, and we can also accept, and we're going to go ahead and do comment and then allow established WAN packets. Okay, and then the last rule we're going to do here is this ENP1S0 drop. So in IP tables there was a concept of a table policy or a chain policy, right? So you could say the forward chain will always drop or the input chain will always drop, and that was always interpreted after all your rules. And it was sort of like the catch-all, right? So you wanted every packet on the chain to drop if none of the rules match. Well, in Nftables, that concept appears to have gone away, or at least I haven't found a good match for it yet. So you have to drop back to your using a catch-all rule at the bottom. One thing those of you who are eagle-eyed may have noticed is this rule really isn't that important right now because we're not actually setting up a rule to drop packets. And the reason we're not doing that is because this rule would just accept them before it got to the drop rule, so it's a bit pointless. Why did I set this rule up then? Simply to show you how to do it. That's really the point there. It's extraneous in this point and you don't really need it, but I wanted to show you that aspect of it. So that's what that's for. So at this point we're basically done with our input rules. We can move on to our forward rules. Okay, so the first thing we're going to do is we're going to go IF EMP1S0 OIF EMP2S0 CT state established and then related, and then we're going to do counter and then accept and then comment and then allow WAN established related. Okay, so what that's going to do is it's going to allow packets to forward if they are established and related from EMP1S0, our WAN, to our LAN, EMP2S0, as long as they are established and related. Okay, so this is going to allow it at the front door, and this is going to allow it to traverse to our LAN. Okay, so the next one we're going to do is we're going to accept connections from our LAN to our WAN. So that's going to be IF EMP2S0 OIF EMP1S0, and then so we don't need the CT state because we're going to trust LAN to WAN because that's coming from us. So we're going to do counter, and then we're going to do accept, and then comment, and then allow LAN to WAN. So this is allowing packets coming from a system on our LAN to go out to our WAN, basically. So what we've basically done is allowed bi-directional packets here. Okay, so now we're going to do IF EMP1S0 IP DADDR 192.168.100.190, which is our IP address for this machine over here. If you guys didn't or can't see that down here, that's the IP address for this machine. Okay, so now what we're going to do is, so basically what this is saying is if the interface, input interface is WAN and the destination address is to that machine, we're going to go ahead and output OIF EMP2S0 TCP dport HTTPS counter accept comment. And this is going to say forward HTTPS. So really what that's doing is it's allowing HTTPS because we're allowing packets to forward that way. So this is 1/2 to a 2-part rule, okay? So if you've ever wondered if you had a router like at your home network or whatever, and you wanted to, you know, play a video game or whatever, and so you need to forward a port in your router, and so you go into your router and you set up port forwarding. There is a few things that it actually does in the background, because I don't know if you guys know this, but routers tend to run Linux. So they're just doing this just in a pretty GUI way. Okay, so this is what they're really essentially doing, is they're setting up the firewall, and it looks something like what I'm doing here. And so basically what this is doing is it is allowing the forwarding of packets from the WAN interface to the LAN interface. And in this case, it's actually allowing it if the condition is destination to this IP address, and the destination port is HTTPS, because I have a way where I'm going to set up a little demonstration HTTPS connection on this guy, and we're going to test to see if we can actually ping the sucker. Okay, so now what we're going to do is we're going to go ahead and drop the remaining packets. Anything that does not match these rules, we're just going to drop it. So if interface EMP1S0 drop. Okay, that's going to drop all packets coming from the WAN interface that do not match the preceding rules. Okay, the chain output, you can absolutely put rules on there. You would probably prefix them with OIF because you're looking at the output interface, right? I don't know if I made that very clear, but input interface, output interface. Okay, so basically, if you've got input, if you're using the output chain, you probably want to prefix it with the output interface because that's going to be relevant to your output chain, right? But really the only reason to manipulate your output chain is if you're paranoid, basically, right? Because basically what you can do is you can use that to, say, limit stuff from going out of your network. So if you're trying to basically prevent people from within your network using certain ports, you could do that. If you're trying to prevent people in your network from hitting certain IP addresses, you could potentially do that. But again, if you're just trying to block malware, I mean, they could just use port 443, and you're going to have that open if you want people using the internet. So is it really going to protect you from all malicious things? No. Could you use it to maybe help a little? Sure. It does add a lot of micromanaging to your table, because basically for every input rule, you're going to need a corresponding output rule if you do that. Again, it's up to you. I'm not going to do it here because it's just too much and I don't want this video to take hours. So at this point, we're done with our INET filter table. Okay. The next thing we're going to do is we're going to define a new table. We're going to define our NAT table, because right now we're just forwarding packets around. Really, we haven't done anything. We're just sort of allowing these things to take place. We haven't actually put rules in to do the actual forwarding yet. So for that, what we're going to do is we're going to set up table NAT. I actually need to go on the other side of this curly brace here and do table and then NAT. And we're going to open another curly brace. We're going to go ahead and do chain output. Okay, open another curly brace, and then here we're going to set up just as you see up here, type filter hook forward, except in this case it's going to be output. So type NAT, because this is not a filter table, this is a NAT table, Our hook is going to be output because we're hooking into an output chain on this one. And we're not really going to use it. I'm just showing you that this chain is a possibility, basically. Priority, I-O-R-I-T-Y. E-R-I-O-R-I-T-Y. Okay. And then minus 100. So let me explain this here. Okay, first type is nat. That's the type of chain that we're working with here. Personally, I think that's redundant. I think you should figure that out based on the table, but it doesn't. You need to actually put the type nat in there, as far as I know. Hook is what kind of hook it's going to hook into. So it's hooking into the output table in nat. And the priority is so you can hook into several different things, and if several different things hook into different things or hook into the same thing, so several different rules hooked into the output rule or output chain, the priority determines where on that hierarchy it falls, right? So the number -100 is something that I picked up from several tutorials. It seems to work well. Your mileage may obviously vary, but if you basically have something where you suspect the priority is the problem, maybe play with the number a little bit. I don't suppose it could hurt much. But, you know, again, your mileage may vary. This is what I've seen in several tutorials, and I believe I've even seen some of these numbers in the man page in Nftables. So, you know, that's where I'm getting those values from. So anyway, moving on, the next chain we're going to use is chain pre-routing. Now we're going to open that up, and then we're going to do another type nat hook, and then pre-routing, because this is going to be the pre-routing chain, and then priority, and again, -100. And make sure you have that semicolon at the end. You will get a syntax error if you do not. And then for this chain, we're actually going to add a rule. And let me just clarify something real quick before we move on. Note that the chain output up there has no rules in it. It's going to stay that way for the duration of this video. Could you put rules in it? Absolutely. Are there definitely things you can do? Absolutely, but it is not necessary for what we are trying to do in this video. The reason I put it there was, one, to show you that it exists, and two, in earlier versions of the kernel, I believe 5.14 maybe ish. Let's see, which one are we on here? Uname. TAC R. Yeah, so I think it was 4.18, sorry, 4.18 I believe, because it's the one before the kernel that Debian 10 actually has, is the one that it affects, I believe. I have read, now I haven't actually tested this, but I have read that if you try to use these tables and you don't define all the chains on kernels before 4.18, you will get errors. So that's the other side of that as well. If you're using Debian 10 or above, you probably shouldn't have to worry about it, but just in case, I wanted to show you how to define all the different chains anyway. So let's go ahead and continue with IF. And so this is going to be the other side of that rule up here, where you're going to create a port forward effectively. So this is the other part of that. So what we're going to do is EMP1S0. That's our WAN port, right? And then TCP, because that's the type of port we're going to use, is going to be a TCP port. And then D port, and then HTTPS, and then counter, and then DNAT, because this is going to be a DNAT. Destination NAT 2, I believe it stands for destination NAT, and then we're going to point to the IP address that we're going to, so that's 192.168.100.190, okay, and then comment, and then our comment is going to be forward HTTPS to 190, okay, and then here we're just going to end that off. And then this is actually the part that's going to make it a router, okay? Chain post routing, open bracket, and we're going to type hook, nat, and then hook, and then post routing, priority, priority, and then this you're going to do +100. Again, I pulled that value straight out of the man pages, so, you know, if you don't believe me, look it up. OIF, EMP1S0 counter masquerade, comment, and then masquerade. Now, at this point, I need to explain the masquerade rule. So this is actually important for routing. It is not our only option. Yes, I will cover the others, or at least one of the others. But this is the one that probably most of you will be interested in, because you probably all have what you call a dynamic IP address assigned to you by your ISP. So if you're trying to make this your primary router for your household, or you want it to route to some system that has a dynamic WAN IP, you're going to want to use Masquerade, okay? So Masquerade is primarily for dynamic IP addresses. If you're using a dynamic IP address on your WAN output, Masquerade is the one you want. Now, you can also use Masquerade with a static IP. However, it is ill-advised, sort of, okay? There's nothing really wrong with it, but just note that Masquerade does incur extra overhead, because Masquerade actually queries for the IP address to find out what IP address it should use. If you already have your IP address because it's static and you know which one you're going to use, it makes much more sense to simply tell it that, so that it doesn't have to query that every single time. Basically, if you don't use Masquerade and instead you use what's called SNAT, you'll save yourself some overhead and maybe get a fraction of a second out of every transaction. So let me go ahead and show you how to do the other one. So the other one, you're going to do IP SADDR, source address, 192.168.100.0, which is the entire network, and then /24. So this is for a Class C network. The /24 is effectively a representation of the subnet mask. So it's equivalent to saying the subnet mask is 255.255.255.0. So basically every IP address within a range that is prefixed with 192.168.100. whatever is going to be included in this rule. That is what I have just said there, okay? So if you were using 192.168.0.0, you would want to use /16. If you wanted 192.0.0.0, you would use /8, okay? So 8, 16, and 24, those are your classes of the networks. If you wanted to specify one IP address, you could just leave off the net mask, or as I did in prior rules, or you could do /32, but I don't think Nftables actually likes that one. In IP tables, you could just do /32 though. I'm not sure if that still works in IP tables, but or in Nftables, I'm sorry. But Nftables, I think, is I think regardless of whether or not it works, you should probably just stick with leaving it off in Nftables because it's cleaner. So OIF, and in this case, we're going to do EMP 1S0, and then counter, and then SNAT, and this is where you're actually going to tell it the IP address. In my case, I'm going to use this because I don't want to actually set up an SNAT here, because it's going to use the WAN IP address, which is the IP address that actually connects to my normal network, so I'm actually not going to demonstrate that. But I will show you what the rule actually looks like. And then SNAT, and then no dynamic IPs, right? Because it does not take a dynamic IP. And that's just for your own information. But that's your SNAT rule, basically. So at this point, I'm going to comment this rule out so that we don't end up with a conflict or anything. And we're just going to close our curly brace, and then we're going to enter down and close our final curly brace. All curly braces should be closed. If you're using a good text editor like Vim or Vi, you may see that it highlights the curly braces like that, so it's really easy to keep track of it. If you're using a bad one like Nano, just for the simplicity of it, then you may have to just eyeball it and make sure you're good to go. But basically, all of your curly braces should be closed. If they are not, you will get a syntax error and your rules will not work. So that's that. At this point, you can save and quit and reload your rules. System CTL restart Nftables. Now, one of the really cool things about Nftables here is that Nftables actually works with systemd. Now, regardless of your opinion on systemd, if you have the systemd init system and everything else on your system works with systemd, it might be nice that your firewall does too. And the biggest reason is that it makes it really easy to manage, because with IP tables, you had to do this funny little thing where you output your rules and you created a script to load them back in and all kinds of jumping through hoops. With Nftables, you don't have to do that. You just do restart, put in your password if you if you're not root or whatever, and then you'll get, well, in my case, I got an error, and it's probably because I flubbed something up somewhere. So let's take a look at that. Sudo journal ctl journalctl tac fu nftables. Yeah, so it looks like we've got an unknown chain. Oh, yep, I did flip it. Okay, so let's go ahead and take a look at that. So let's see. There it is right there. So basically I've transposed a letter. So we're going to go ahead and fix that. Just like so. There we go. And let's try again. Let's see what we get. And looks like we've got another bug somewhere. I don't know where yet. So let's take a look at the output. Okay, so let's take a look at the rules and find out what's going on. So statement after terminal statement has no effect. I think it was this one here. Well, I don't think I actually require that bit anyway. Okay, so I see the problem. The problem is definitely that we have another typo. I just transposed another letter here. So there we go. Okay, so now we should get what we're looking for here. So let's take a look. Start Nftables, and we're good. Okay, so now we should, in fact, be able to ping some Google. So let's check. And you can see that we have a ping. Okay, and you can see that if we ping 8.8.8, we're good there too. Good to go. All right, so you can see now that we can ping out from behind our router, which is awesome. That's exactly what we want. However, if you remember, we also set up that port forward that I literally just struggled with for a little bit. So let's take a look at that and see if we actually got that working. So we're going to use a little command called netcat. I actually have it in my history here, so I don't got to remember what it was, but grab and see. Yeah, so this is what we're actually going to do right here. Okay, so what this is going to do is it's going to set up netcat, it's going to tell it to listen, it's going to tell it on port 443, and it's going to give you a V, a verbose output. So when something connects in, you should see it hit that system. Okay, so now what I'm going to do is I'm going to go ahead and move this terminal into action, okay, and we're going to use this to actually hit this server. Okay, so what we're going to do is we're going to use a command called Nmap, and we're just going to try to hit that system from behind our router. And you can see here the connection is open, okay? Now all this stuff up here is going to be blurred out basically, but you can see that this IP up here that's blurred is going to end up being the WAN IP address of our system, okay? And then all this is going to be a bunch of blur for you guys too, because it has some network proprietary stuff, possibly also the rest of this down here as well. But the important thing is that you can see that we have an open port here, which means we are able to hit that. So to explain our command here, you have an nmap command. So let me just do it down here in a way that I'm actually going to blur this a little bit too, but I'll unblur it when I get to the point where it's necessary. So 443 and then 0.0.0.0 and then tac S and then capital S. So to explain the command that I've done there, basically I've told it to use the nmap command, and I've told it to use it on the port 443, so basically look for port 443, and then I've told it to you this is going to be a placeholder for the WAN IP address that you're going to use, and then this SS here tells it to effectively only do simple SYN requests and don't try to do a SYN ACK. And the important thing about that is when you're setting up a netcat listener on the other side, you're faking an HTTP server. That's not a real HTTP server, it's just a fake one, okay? All you're doing is telling a program to listen on 443 to fake like there's something there. And netcat has this thing where whenever it gets the complete handshake, it's going to hang up the connection. So the problem is that Nmap, if it gives it the complete handshake, it's going to hang up the connection, and Nmap will report that the port is closed even though it's not. So the tac little s big S there at the end tells it don't send it the complete handshake, and instead just send it the simple handshake and have it tell you if the port is open or not. Actually, there is one more thing I do want to show you now that I think about it, so let me close that window. So what this command is it's combining two commands. You have the watch command here, which is tac in1. Tac in is for your It's like a number counter, basically, and 1 means 1 second. So basically, every second, you're going to repeat the command in quotes. Now, you don't necessarily have to quote the command out here, but if you've got arguments or something, or switches or flags or whatever in the list, like tack in or whatever, or if your command contains a space, then you need to quote it in order for it to work. But basically, what this is doing is it's saying NFT, it's using the NFT application. You're saying your action basically is going to be to list the table, and you're going to list inet filter. Now, if I press enter, you'll see that I get this filter here, right? And this is basically going to give me an output for my various tables and my various chains on this filter table, okay? And you can see the packets going up here for SSH. You can see here I've got packets counting up here. You can see that I've had those packets from where I did the Nmap to attach to this system here. And that is as a result of that counter, right? So anywhere you have that counter, that's where you see that. Now, obviously, this one is not. Obviously, everywhere you have the word counter, basically, that's what it'll add this this value, these values in here. It'll show you the number of packets and the number of bytes that have traversed that rule. Obviously, you can leave the counter out if you want, but you just won't see that output. So this tells you basically, is your rule doing something? Is it actually working? And that's how you kind of replicate that Iptables, tac capital L, tac B, tac N. If you want to see the NAT filter, the NAT table, you would simply change inet filter to NAT. And here you can see your NAT table. And here you can see if you've got a counter, you could do that. Now again, that second SNAT rule will not be there because we commented out. These rules are there, they're active, they're obviously doing something, and so that's that. So that actually completes the tutorial. I hope you guys have learned something. I hope you enjoyed it. Yeah, good luck on your network filter table endeavors.